Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in unit 3. We are going to see restoring division. So far we have seen different types of adders, multipliers and fast adders and fast multipliers and all those things, right? And today we're going to see division, okay? In division you have two types. One is restoring division and non-restoring division, and in this video we will see restoring division, right? So before going to restoring division, we'll just see the normal division which we do, right? This is the decimal division, right? So the divisor is 13 and the dividend is 274, right? So what I will do is I'll put 2 here, so it is 26, and the remainder will be 1. So I'll bring this 4 down, right? And you normally know this, right? So I put 1 here, so 13, so the remainder is 1 and the quotient is 21, right? Similarly, for binary, we will go for the long division method, correct? Right? So if you see this one, right, this is the dividend and this is the divisor, right? So till this point, this is very lesser. So I'm taking this 5 digits so that we can able to divide. So it's 1. So 1, 1, 0, 1. So if I go to subtract this, so it's 1 minus 1, 0, 0, and it's 10. So if you borrow here, it's 10, right? 10, 1, so it's 1, right? And now you can listen very carefully. Now we are bringing the 0 here, and if you put 0, right, you cannot able to divide because it is lesser. So I am putting a 0 here again, right? So and again now I am bringing the 0 here, and now I can able to divide. So I am putting 1 here, and I am putting 1, 1, 0, 1, right? And if you want to subtract this, what will happen? Right, this will become 10, right? So that is you have to borrow from this one, right? So this one will be gone, right? And all this will become ones, right? This will become 1, 1, 1, and this will become 10, correct? Right? So what will happen? 10 minus 1, it's 1. So it's 1 of 0, it's 1, right? And now what will happen? You will bring this 1 down, right? And you cannot divide, so I add a 0 here, right? And you bring this 0 here, and now you can divide, so I put 1, and if you're going to subtract, you'll get this 1, right? This is the normal division which you do, correct? Right? And now we'll see another example, a simple example to explain restoring division, okay? So you can see here 11 is the dividend here, and 1000 is the divisor. Sorry, 11 is the divisor and 1000 is the dividend, okay? So now 11, so I'm putting 1 here, so I can take 3 digits, right? If I'm going to subtract this one, what will happen? Right, 10, this will become 1, right? I'll borrow this one. So 10 minus 1, 1, and this will be 0, right? And bring the 0 here. So 0 and 0, correct? So quotient is 0 and remainder is, quotient is 10 and remainder is 10, okay? Now we will go to restoring division, okay? Restoring division, you have a simple logic, okay? That is, see, if you look at this logic, it will be confusing. If you look at the example and we come back to this, it will be very easy for you. This is long division method. That is just the division which we have done here, right? It just explains this process, okay? First, what we have to do, you have to place the divisor, right? And then you have to subtract that, right? And similarly, you have to put 0 or 1 in the quotient, right? And then you have to once again subtract with the divisor, and the process continues until you get the remainder 0 or 1, correct? Right? So this is long division method. That is these are the steps which we follow, right? And you can see this is the logic of restoring division, okay? And this logic, this is just explains how the circuit works, okay? I'll just explain that little later, okay? Restoring division, this circuit I'll explain little later. Now we will see the logic of it, okay? So this is the logic. You can see you have 2 registers. We will put 2 registers. That is, one is accumulator, another one is Q, okay? That is Q. You can see here, right? Q is nothing but we will place the dividend, okay? Accumulator is we'll just use for storage purpose, right? So dividend. So for every operation, right, that is, you have to shift one left position, that is A and Q, right? And then next one, what you have to do is you have to subtract. So you have to subtract M from the accumulator, right? What is M? M is nothing but M is the place where you will save the divisor, right? So you understand, you have three registers, that is one is Q and one is M, another one is accumulator. Okay, you will say divisor in M, dividend in Q, and accumulator is for storing purpose. Okay, and the first logic is you have to shift A and Q one binary position, and then what we have to do, you have to subtract, right? You have to subtract the divisor, right? That is M from A, from the accumulator, right? And you can see here, this is the main logic. If the sign of A is 1, then you have to set Q0 to 0, right? And then you have to add A, right? That is, you have to do a restore operation. Otherwise, Q0 is equal to 1, right? Like, if you don't understand this, just we will see the problem so that you can clearly understand. Okay, we will take the same example. Like, I take the dividend 1000 and the divisor as 11, right? So I'm going to divide this 1000 by 11, so you'll get remainder 10 and as well as quotient 10, correct? Right? Now we'll see here. So here, understand one main logic here, right? That is, first thing is you have to save the divisor, correct? What is the divisor? Dividend is 1000. 1000 is saved in Q, correct? So this is Q value. So what I'm doing is I'm putting it 1000 here, correct? Right? And now I have to place the divisor in M, right? So what is the divisor? Divisor is 11, right? So it is, that is 0011, right? 0011, correct? Right? And now you can see everything is 4 bits here, right? And initially the accumulator value, listen the logic very carefully. This is the accumulator value initially, okay? Right? And now listen very carefully. We'll use 4 bits, but for accumulator initially there will be 5 bits. That's because this is signed bit. Okay, so because of that, I will convert this divisor also 5 bits. Okay, because that has to be added with the accumulator, right? Now understand the logic, right? The main logic here is, first thing is you have to do a shift operation. First step, you have to do shift operation, and then second step you have to do subtract operation, right? And the third step you have to do restore operation, right? You can see here, that is, you have to do shift operation, subtract operation, and then you have to do a restore operation. Okay, and one thing is you have to set Q0, right? That is, the restore will be done only if there is 1 here. If it is 1, we have to do restore. If not, we should not restore it. Okay, so understand this. Now initially you can understand this one. Okay, right? So now first step, what we have to do, the first step is you have to shift operation. You have to perform shift operation, right? So what I'm going to do is I'm going to shift this one. Okay, so I'm going to shift this one. This place will become empty, correct? So this will become 0, and this 0 will be here, right? And this 0 will be here, right? And this one will come to this accumulator position 1, right? And this will become 0, right? And this will become 0 and 0, right? 4 and then 0, correct? Right? So this will be, after shifting you'll get this one, right? Now listen very carefully. Now we know that this is the divisor, correct? So this is the divisor. Now what we have to do is we have to take the 2's complement of it, right? That is, we have to do a subtract operation, correct? So for addition, right, we will just use same like the multiplier, right? What you will do, you will just add the multiplicand, right? That is, if it is 1, if it is -1, what you will do, you will take 2's complement of it, right? So now this, we know that this is the divisor, right? So what I'm going to do is I'm going to take 2's complement of it. If I'm going to take 2's complement, first I have to take 1's complement of it. So now I'm going to add 1. So now you can see 1, 1, 1, 0, 1. This is the 2's complement of number. So now we have done the shift operation, correct? So we have done shift operation, right? And now what we have to do, we have to do the subtraction, right? That is the second step. First step is shift, second step is subtraction, right? So for subtraction, what I have to do, I have to use 2's complement of it, right? So 1, right? So now what I have to do, 2's complement, after doing it, you have to add, correct? Subtraction is nothing but, right? Take 2's complement and add it, correct? So now 1 plus 1 is 0, correct? So it's 1. And it's 1. So it's 1, 1, 1, right? And we already know we have here, right? We have this number, right? Now you can see this is the signed bit here. Listen very carefully. This is the signed bit. Okay. Now what we have to do, this place is empty, correct? Right? And now what we have to do, if this is 1, right, I have to put the Q naught as 0, right? The complement of it, that is this value, right? This value, I have to change it as 0, right? The complement of it. Remaining part will be the same, 0, 0, 0. The triple 0 will be the same, right? So if it is 1 here, you have to change it 0 here, right? And if it is 0 here, you have to put it 1 here, right? And next one, if it is 1 here, you have to do a restore operation, right? What is a restore operation? So since it is 1, right, what we are doing is we have to add the summand, right? That is, sorry, divisor, right? This is the divisor, right? The normal divisor, 00011, right? So I'm going to add 00011, okay? Right. So if you add, what will happen? 1. So it's 10, 1 carry. 1 plus 1 is 10, so 1 carry. 1 plus 1 is 10, so 0, 1 carry. So it's 10, so I can put only 0 here and 1 is left, okay, because I can use only 5 bits here, right? Clear with this? Okay. Now this is one cycle. Now this is one cycle, okay. You can see this is the shift operation, this is the shift operation, and this is the subtract operation, and this is the restore operation, right? You can see here shift operation, subtract operation, and this is 1, so I have changed it here, and what I'm going to do is I'm going to do a restore operation, right? So you can see what is the value you got here. So it is 4 zeros and 1. Got it? Right? The same step, the next step what we have to do, we have to shift, right? How will you shift? You have to shift the 0 here, right? And again shift like this, right? So this is second cycle. You can see here, I'll explain here, okay? So this 0 comes here, so this 0 comes here, 0 comes here, 0 comes here, and 1 comes here, so everything comes here, right? And now what you have to do, after shift, what you have to do, you have to do subtract operation, correct? So subtract, now normally once again, you will use 11101, right? And if you use 11101, what will be getting? 1, right? 1 and 1 here, 1 here, and 1 here, correct? So you'll get this answer, correct? And now once again, what are you getting here? This is the 1, right? So if it is 1, what I will do, I will convert it to 0, correct? Right? So if it is 0, 1 here, what I got to do? I got to do a restore operation, right? So it is nothing but 00011, right? I'm just eliminating the 0 and writing only 1, 1. Okay? So if you add, what will happen? 10, so it's 1 here, so it's 11, 1 here, 1 carry, and again 10, right? And it's 1, so it's 10 again, it's 1 and 0, 1 is left out, okay? So this is the 1, right? And now what you have to do? You have to do again shift operation, correct? So this is second cycle is over. 1 shift operation, 1 subtract operation, and 1 restore operation. 1 cycle is over, right? Now again, what I will do? I will do the shift again. Again, I'm shifting, right? And then I'll subtract, right? Now listen very carefully. Now while subtracting, what you're getting this particular value, right? I'll use a highlighter. You can see here while subtracting, you're getting this particular value, right? So if it is 0, right, what you have to do? I have to write 1 here, right? You have to write 1 here because you have to write the complement of it, correct? Right? And then what you will do, right? You will normally do restore operation, correct? So if it is 0 here, there is no restore operation, right? So if it is 0, there is no restore operation. If it is 1, you will do a restore operation. You can see here, if it is 1, you do a restore operation. Here is a 1, you do a restore operation. Here it's 0, there is no restore operation. So what you have to do, you have to use the same value, the same accumulator value, 00010, right? The same value here, right? You have to use the same value, right? Don't get confused here, right? That is, you have to use the same value here, right? So what will happen here? Now I'll do the step here. Listen, I'll do the step here. So it's 0, 0, 0, 0, 1, correct? Right. Now what you will do? You will put this 1 here, correct? And then you'll have 000, correct? So far clear? And there is no restore operation. So what I will do? I will write the same steps here. and write the same steps, that is same value here, right? Because the accumulator value, this step is missing here, okay? And now what I will do, I will do the shift operation. So what you will do, 1, right, 0, 0, and again this 0 will come here, 0 and 1 here, right, and 0 here, right, and 0 here and 0 here, correct? Right? Now what you have to do, you have to obtain this one, correct? And now what you will do, you can see this is the value you have obtained here, correct? Now what you have to do, you have to do subtract, right? So what will subtract? 111 0 1, right? You will subtract this. Subtract in the sense it's addition. 1 1 1 1 1, right? So this is 1, right? You got it, right? So now you understand the third cycle, right? You can see here the third cycle, triple, see everything is 1 here and everything is 1 here, right? And now what you will do, you will bring this 1, now you will bring this 1 0 here, correct? So you'll get the remainder as 1 0, correct? Right? And now it is 1 here. So what I will do, I will do a restore operation, correct? So if it is 1, we have to do a restore operation, and if you do a restore operation, you'll get the 10 here, correct? So you can see the remainder and as well as quotient is 10, which is the same one which is obtained. Remainder and quotient is 10, right? You understand what we saw so far, right? So restoring division is very important question, right? All you have to do is you have to understand one particular logic, that is you have shift operation, you have subtract operation, and you have restore operation, okay? Right? Now you're clear with this, so now you can understand this logic, right? So wherever you have to shift and wherever everywhere you have shift and subtract operation, right? Only thing is restore operation, if it is 1, then there will be a restore operation, correct? Right? Now coming to this particular thing, right? This is the restore division, right? The circuit I will explain, right? So you can see here n-bit positive divisor is loaded in M, right? And dividend is loaded in Q, and A is first set to 0, right? Right? And then what you will do for subtraction, you will take 2's complement of that divisor, right? And then for extra position, right, what you have to do, you will do shift every position, you'll have a shift operation, correct? Right? So that is what we will do here, right? Now while implementing this circuit, you have to understand, right, there is add and as well as subtract operation, correct? Right? We know that if there is 1, correct? If there is 1, sign bit is 1, what you have to do, there will be a restore operation, that is we have to do a addition, okay? And apart from it, normally you will have the subtract operation, you will use 2's complement, correct? Right? Now you can see here, depending upon this Q0 value, right, as like the multiplier, right, the accumulator will be initially 0, it will be filled with the dividend, stored in Q, and divisor will be stored in M, right? And this control sequencer will shift the operation whenever we need it, it produces shift operation, right? And depending upon this Q0 value, it will tell you whether we have to add or subtract, right? So that the accumulator value will be added here or it will be subtracted, right? For subtraction, it will use 2's complement of it, correct? Right? So this is a restore division, right? Hope you understand the logic behind this, okay? And you can write the flow chart similarly, right? The same steps. First, what you have to do, you have to shift A and Q, right? And after that, you have to subtract, right? So while subtracting, right? While subtracting, if you find the accumulator sign bit, right? If it is greater than 0, that is, if A is equal to 1 or A is equal to 0, correct? If A is equal to 1, right? If A is equal to 1, what you have to do? You have to do a restore operation. You got to see here, if A is equal to 1, yes. If A is equal to 1, you have to put Q0 as 0 and you have to add A plus M, right? And if it is 0, then there is no restore operation, correct? So you have to just put Q0 is equal to 1, right? And this process continues until the count reaches 0, right? Right? And the remainder, right, the quotient is Q value and the remainder is at the A value, correct? This is the logic of a restore division, correct? Right? So today we have seen what is restore division, right? So in restore division, what we have done is we have seen the main logic of restoring division, the shift operation, subtract operation, and restore operation. If you understand this logic very clearly, you can definitely complete it, right? Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.